Hello everyone, this is Lalita ma'am and welcome to my YouTube channel. So today I have come up with chapter 1 motion for class 9th. Okay, so without further delay, let us explore today's topic. Okay, so in today's lecture, we are going to cover these points: mechanics, rest and motion, scalars and vectors, reference point, and distance and displacement. Okay, so let us slowly try to understand each topic one by one. Okay, now what is mechanics? To understand what is mechanics, let us try to understand first from where did it come. Okay, what is the history behind it? So if you talk about science, it is a very broad concept. When you study about nature and all the natural phenomena, that study comes under science. Okay, now science itself has many categories. Like it is divided into different categories like physics, chemistry, bio, and like different subjects it has. Okay, so depending upon what study we do, it comes in that way we divide it. So mechanics, now as physics is a branch of science. Okay, so now mechanics is a branch of physics. Okay, now this mechanics deals with the study of the objects that are in the state of rest or when the objects are in state of motion. Like for moving objects or for stationary objects, when we perform some studies on them, then that study comes under mechanics. Now mechanics itself is divided into two categories. One is statics, other one is dynamics. Now this statics word, it itself has its meaning lying in it. Statics word comes from the word stationary. Now stationary means which is not moving. And the next one, dynamics, it is the study of objects that are in motion. Okay, now if you talk about motion, the object can be in circular motion, straight line motion, or random motion, zigzag motion, different ways. But when you talk about specially the objects that are in straight line motion, or when you study about the objects that are in motion irrespective of the cause of the motion, like without knowing the cause of the motion, when you study about the motion of the object, then that study comes under kinematics. So statics is the study of objects that are stationary. Dynamics is the study of objects that are in motion, and kinematics is the study of objects that are in motion irrespective of the cause of motion. Okay, so now what are the different types of motion? Okay, now motion, as we have already discussed just a few seconds before, like motions can be in a different way. Like the object can move in a straight line path, the object can move in a circular path, the object can move in an oscillatory path like to and fro, or the object can move randomly like in a zigzag manner, and so on. Okay, but so depending upon what type of motion it performs, there are different types of motion. Like if an rectilinear motion, that is motion in a straight line; circular motion, when an object moves in a circular path; rotational motion, like the motion of earth around its own axis; then oscillatory motion, motion of the pendulum of a clock, to and fro motion of the pendulum of a clock; then random motion, motion irrespective of anything, like simply moving in a zigzag manner. But in this chapter, as motion itself is a very big concept, but in this chapter we will deal with only two types of motion, that is motion in a straight line, which is also referred to as rectilinear motion. Rectilinear, linear means in a straight line. So in this chapter we will study about the objects that are moving in a straight line, and also the second part or the very small part of this chapter is uniform circular motion. Okay, so let us see first what is motion. Let us try to, we are talking so much about motion, different types of motion, but first let us understand what is motion. Yes, so now to understand the concept of motion, Okay, in simple words, like generally in speaking to our general terms, when someone moves from one place to another, we call it as motion. Yes, but in physics, the definition of motion is different. It has a different concept. Okay, simply if someone changes the position like from one place to another, that is not motion, but you need to have something reference to, with reference to which you observe it. Like for example, in this slide you can see there is a man, there is a tree, and there is a train. Okay, now this train is moving. Okay, let us assume that this train is moving, and that man and tree, they are fixed to their positions. Okay, now for the man who is standing beside the tree, for that man, that tree is not changing the position. Yes, not even now, not even after some time, not even after 1 or 2 hours, not even after 1 or 2 days. Yes, so for that man, when the man unless until the man doesn't move, for him the tree also doesn't change the position. So for the man who is standing there, for that man, the tree is not changing its position with respect to time and with respect to observer, the man. So when the object does not change its position with respect to time and observer, then that object is considered to be at rest. So in this case, tree is considered to be at rest with respect to man, and man is considered to be at rest with respect to tree. Because for tree also, the man remains in the same place unless until he doesn't start moving. Yes. So they both are at rest with respect to each other. But now when the same man and same tree, when they are being observed by a passenger who is sitting inside that train. Okay, let us assume that you are sitting in that moving train. So when you observe them from the window of the train, for you, man and tree both will appear to change their position. Yes, so as man and tree both appears to change their position with respect to time and with respect to you sitting inside the train, that is why the same man and the same tree will be in the state of motion with respect to. This is important. The man is stationary with respect to tree, tree is stationary with respect to man. But they both are in motion with respect to the passenger who is sitting inside the train. Because for that passenger, for that person, both tree and man appears to move or change their position. Why? Because actually the train is changing the position. That is why the person who is sitting inside the train, for that person, they appear to change the position. So let us now define rest and motion. I hope it is clear to you. Yes. So a body is said to be at rest if its position changes with the a body is said to be at rest if its position does not change with respect to time and observer. This is important. Time and observer. Observer is also important. Like with the change in the time, if the position changes, or with a particular observer, if the position changes with respect to a particular observer, then it comes in motion. Or else if the position does not change, it remains fixed, then it is called as rest. So rest will be defined as a body is said to be at rest if its position does not change with respect to time and observer, and a body is said to be in motion if its position changes with respect to time and observer. Okay. Now, do you know, let us think little broader, in a broader view. Do you know that plants also show motion towards a stimulus? Now you might be wondering, how come plants do not change their position? Yes, but towards the stimulus means you might have heard about phototropism and all. Yes, phototropism, photo means light. Like plants start moving in the or plants start growing in the direction of light. Now when you observe the motion of these plants for a very short for some interval of time, let us say for one day or for some hours, then you will not be able to notice their change in the position. Yes, you will not be able to notice the change. But if the time interval is little longer, like if when the seed is sown and it becomes sapling, then it becomes a tree, like then in that case it takes years, like okay. So when the period of time is years, or when you observe the change over years, then in that case also plants also appears to move. Okay, they also appear to move. Now these movements are very slow, so we cannot consider it actually, or we cannot observe this type of motion in a small time interval. Yes. Now also one such type of motion is the motion of hour hand of a clock. In a clock we have seconds hand, minutes hand and hour hand. Now the seconds hand, it starts moving very fast. Yes, within for every second it changes the position. If you talk about a minute hand, that minute hand changes the position after every minute. So that time interval also is very small. But if you talk about hour hand, that hour hand does not change the position in small period of time. It requires after 1 hour or after some minutes it changes the position. So if you want to observe that change, your time interval should be long. And if you consider the motion of the hour hand for few seconds, then for that, according to that, there will be no change in the position of the hour hand. So hour hand will be considered at rest. Okay. Now let us go through, try to solve these questions. First question. You are moving towards Taj Mahal. Okay. You went to Agra and you are moving towards Taj Mahal. So is Taj Mahal considered at rest or in motion with respect to you? With respect to you. Okay, that is important. So you have to answer this question by considering you yourself as the observer. Okay, so try to find out the answer. Then one more question, two trains A and B. There are two trains. One is train A, another one is train B. Those two trains, they are moving on the parallel tracks. Parallel tracks in the same direction with the same speed. Now there is an observer who is sitting in this train A. That observer is P. Another observer sitting in this train B. That observer is Q. So for P, whether Q is in rest or Q is in motion, or for Q, P is at rest or P is in motion. Okay, so you have to find out these answer. Now from this question, like one more small thing I would like to clarify to you. From this we can conclude that motion and rest, they do not have a fixed terminology, or we cannot say that same object can be at rest, same object can be at motion if the observers are different. Yes, so these type of terms that changes with the observer or with the change, these type of terms are called as relative terms. Relative terms means they depend, they are related to observer, है ना? So these are known as relative terms. And so rest and motion, they come under relative terms. Why rest and motion are relative? They are not absolute. Whether it may be asked in the exam, like are motion and rest absolute or relative terms? So they are not absolute. They are not fixed. Okay. For the same object can be, if it is asked to explain why motion is a relative term, so you can say like motion and rest, they are relative terms because same object can be considered at rest for one observer, and this same object can be in a state of motion for another observer. That is why it is considered, it can be so that is why these terms are relative terms. Okay, now let us go to the next topic, that is scalars and vector quantities. Now let us try to explore more about scalars and vector quantities. Now suppose when you go to market, okay, and you purchase vegetables. Okay, you'll go and ask, Bhaiya, give me 1 kg of potatoes or tomatoes or whatever, 1 or 2 kg. So there you do not need to mention, like if you ask the shopkeeper or if you ask the grocer to give you 1 kg of tomatoes, then that information is complete. It makes a sense. Yes, you don't need to tell something else to him. Okay, give me potatoes in north direction, give me potatoes in south direction, like that. No, simply if you say give me potatoes, 2 kg of potatoes, so that 2 amount, that is called as magnitude, and kg, kilogram, is the unit to represent that amount. Okay, to represent that magnitude. So that when it makes a complete sense, okay, so then such physical quantities are known as scalar quantities. Means the physical quantities that do not require direction to represent them, that requires only magnitude. Now magnitude means that 1, 2, 3, 4, these numerical values. These values are known as magnitude. So when any physical quantity makes a complete sense just by its numeric value, then that physical quantity is known as scalar quantity. Like mass, 1 kg, 2 kg, these complete sense. Time, if somebody asks you what is the time, you will say it's 2 o'clock. Or how much time did you study? So I have studied for 3 hours. So it makes a complete sense. It gives a complete information. So how long is your school from your home? How much distance it is? So you will say 1 kilometers, 2 kilometers, depending upon whatever it is. So it gives a complete sense. So such type of physical quantities that requires only magnitude to represent them, they are known as scalar quantities. And these scalar quantities, they obey the normal algebraic operations. Normal algebraic operations means like 2 kg of potatoes plus 5 kg of potatoes will definitely be 7 kgs. There is no other possibility. Yes, it cannot be negative 3 kg. Yes, so such type of physical quantities are known as scalar quantities. Now let us see what are vector quantities. Now the physical quantities which require magnitude as well as direction both to represent them. Now what does it seems very difficult, isn't it? It looks very difficult, but it's not at all difficult. Now let us try to understand with one example. Suppose you are in an army, okay, and you are an army officer, and you receive the instruction from your higher authorities, like it's emergency, so move 5 kilometers, okay, because the enemies are going to attack, and then the phone gets disconnected. Okay, so then at that time you are confused. Okay, move 5 kilometers. So, but where to move? Whether to move to the north, east, west, south. You don't know from where the enemies are going to attack you, isn't it? So then you are confused. That information is not complete. So there, to understand or to understand in which direction you have to move, to understand where to move, you need to understand in which direction also. Without that direction, that information is incomplete. So such type of in such cases, those quantities will be considered as vector quantities. For example, force. Okay, I'll give one example. Suppose if this is one object, okay, on this object a person A is applying a force of 5 Newton towards left side, okay, and one person is applying a force of 2 Newton towards the right side. So left and right together, from here 5 and from here 2 together, like the actual impact will be 5 minus 2, 3 Newton. Yes, or suppose if if an object is kept here and 5 Newton from here and 5 Newton from here, so will this object move? No, the object won't move. Yes, this object will not move at all, because this 5 from this direction and this 5 Newton from this direction, both will cancel each other's effect. That is why there is no net movement of this object. Okay, so that is why force comes under, like direction plays a role here. Yes, what I want to say is direction plays a role here. That is why such physical quantities that requires or that depend upon the direction, those physical quantities are known as vector quantities. Okay, as we'll study more in this, as we'll explore more this chapter, you will understand vectors one by one and easily. Okay, now one more, the next important point which while studying about motion of any object is reference point, to understand what is reference point. Now recall the example of that man, tree and train. The man, when we are considering the man as the observer, so the position where man is standing, that position is known as reference point. Okay, and if the motion is being observed by the passenger who is inside the train, so the place where he is sitting, that is known as reference point. So simply reference point can be defined as the point from where the motion is being observed. Okay, so we can also call it a starting point of any motion. Yes, so the point from where you start observing any motion, that is known as reference point of that motion. Okay, and always the reference point's value is 0. So the point from where the motion is being observed is known as a reference point, and the value of reference point is always 0. Okay, and generally this 0 is also known as origin. You have already studied in maths. Yes, origin is at 0. The 0 point is known as origin point. So reference point is also known as the point of origin. Now let us understand what is distance and displacement. Sometimes we feel like, are they different? No, they seem to be same, isn't it? Distance or displacement, it seems to be same for us. But in physics, they do have a different meaning. They are two different things. How motion and rest, they are relative terms. In the same way, like this distance and displacement, they are really different from each other. Now let us see how they are different from each other. You will understand more about their difference as we explore more about this topic. Okay, now what is distance? The actual length of the path. Suppose you start your motion from your home to school. Okay, so you started from your home and your school is, let us say, 4 kilometers away from your home. So from home to school, when you go, you might have traveled different paths. Yes, your auto wala bhaiya might have taken you to different students' home. Like you might have gone to different students, and from there, like when you move from one place to another, and finally you reach your destination is actually your school. So from your home to school, the total length of the path, that zigzag path in which you moved, that length of the path is known as distance. But instead of going to different places, instead of going by school van, if you would have gone with your parents or in your bicycle, then you would have definitely gone to the shortest path. Yes, why will you go or roam here and there? So the shortest path between your initial and final point, or your starting point and your destination, the length of that shortest path is known as displacement. Okay, so distance is total length of the path. Okay, displacement is the length of the shortest path from initial and final point. Yes, now let us understand more about distance and displacement with this example. Now in this slide, you can see home, tree. There are two trees in two different positions, A and C, and B position is for home. Okay, so one boy, he starts riding bicycle from A to, actually he has to go to C. So, but directly, instead of going directly from the shortest path AC, instead of following that, he goes from A to B, then B to C. So the distance between A and B is 4 meters. The distance between B and C is 4 meters. 3 meters. So the total length of the path which he traveled will be 4 meters plus 3 meters, that is 7 meters. Yes. Now instead of following that path, if he would have followed the shortest path from A to C, now always the shortest path between any 2 points is the straight line path. है ना? If you want to move from one point to another, you go in this way, that way, in a zigzag way, or in any way you go. But the shortest path will always be straight line path between initial and final point. So if the boy would have gone from the straight line path from A to C, then the distance would have been 5 meters. Yes, 2 meters less. Okay, so now here let us try to understand what will be the distance covered by this boy and what is the displacement. Okay, means from your initial point, how much far you are, from your initial point, how much actually you are far, that is called as displacement. So here distance will be AB, length AB plus length BC. So that AB plus BC means 4 plus 3, that is 7 meters. But displacement is AC, that shortest distance. So shortest distance is AC. So that is 5 meters. So are they same? No, 5 and 7 are different. Yes. So they are different. Distance and displacement, they are different from each other. Okay. Now a question also comes in mind. Can displacement be 0? You might be thinking, how is it possible? Displacement, if a boy has moved from one place to another, it cannot be 0. Yes? No, it can be 0. And when will it be 0? There is a condition for it. Let us try to understand by this first example. In the first example, you can see the motion starts from A, then it goes to B, then B to C, then C to D, then again C to D to A. So the starting point is A, the end point is also A. So in such cases, if I have started from here, then I traveled to different places and I reached here, back again. So the shortest path between initial and final point. Now this is only initial, this is only final. So same initial and final point if we have, so displacement will be 0. Means I have not moved, I have not displaced from my place. I came back to my own place. So my net displacement is 0. Okay. So displacement will be 0 only if initial and final points are same. Only in this case distance and displacement will be 0. Except this, in all other cases displacement will not be 0. Okay. Now one more thing, can displacement be negative? Then again, how is it possible that displacement be negative? If yes, then how is it possible? You have to tell. Yes. So let us try to understand this second example. Now this second example shows us, it tells us that you can see or you can observe the boy initially he was at 0. So 0 means that was origin. Okay. From 0, let us consider that the boy is moving in a number line. Yes, he is taking steps in the number line. Number line, you all know, a line which has 0 in the center, and then on the left side we have all the negative numbers. On the right side we have all the positive numbers. So the boy is at 0 and he is asked to take 5 steps front or towards the right side. So 0 to 1, 1 to 2, 3, 4, 5. Okay. Then he was asked to take 10 steps back. So 5 to 4, 3, 2, 1, 0. It is only 5. He has to take 10 steps. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay. So in that way, if you see, the boy will reach to negative 5. So the displacement traveled by that boy will be 0 to negative 5. That is negative 5. Okay. So in this case, displacement is negative. But if you ask, like if you try to find out the distance covered by this boy, then it will be 0 to 5, 5 steps, then 10 steps behind. 5 steps ahead and 10 steps behind. So 10 plus 5, total 15 steps. 15. So distance will be 15 and displacement will be negative. So from this we can conclude that displacement can be negative. Now now we have understood what is distance and what is displacement, let us try to find out the difference between distance and displacement. Okay, so the difference between distance and displacement. Distance is defined, first you will write down the definition, what is distance, what is displacement. Okay, so the distance is the actual path length covered by any moving body, the total length of the path. If any object is in motion, so how much total length of the path that object has covered, that is known as distance. And displacement will be the shortest distance between initial and final position. Okay, that will be displacement. Now, does distance depend upon direction? No. Whether the boy goes forward, backward, in any direction anyone goes, only we need the total length of the path. So for finding the total length, we don't need to depend on which we can ignore direction. In whichever direction he goes, we simply need how much distance, how much length he has covered. So simply add up, it will give you the distance. So direction is not associated with distance. So what type of quantity if direction is not associated or if direction is not required? So distance, yes, you are right. Then distance comes under scalar quantity. We have already studied it before. Yes. Now direction is associated with displacement because suppose if in the example which we have studied previously, like in that example we have seen the boy, instead of going back 10 steps, if the boy would have gone 2 steps more ahead, then 5 plus 2 7. So then displacement would have been 7 in that case. Yes, but as he changed his direction, so the displacement also changes. Means when you change the direction, displacement changes. Means displacement depends upon direction, and as displacement depends upon direction, so it will be a vector quantity. Now we have already seen like distance will never be 0 because if the object has started and if the object is moving, so definitely every moving object will have or will cover some distance. So distance can never be 0. It will always be positive. It will never be negative. So just reverse to it. Displacement can be positive or it can be negative. And it can also be 0 also. We have already seen that example of 0 displacement. Okay. Now, there is one question for you. You solve these questions, the previous 2 questions and this question, and do comment the answer. Do write answer in the comment box. Okay. I'll reply to your answer whether you are right or wrong. Okay. Let's see how many of you are able to solve these questions. Okay. In this question, let us see what is this question about. There is a circular track and the circumference, you know circumference, the length of the boundary of the circle. It is known as circumference. So the circular track has a circumference of 314 meters and AB is the diameter of that circular track. So there is a circular track and AB is the diameter. Diameter, you know? Yes. So the line that passes through the center and from one point to the other point. Okay. Now a cyclist travels from A to B. So if this is A, cyclist travels from A to B like this. Okay. Half of the circle. Then along the circular path with a velocity of 15.7. Okay. With some velocity means that speed. Now how much distance the cyclist has moved. You have to find that distance. So it is something related to this circle's half. Okay, this is a clue. Okay, you can find out from it. And how much displacement is covered by the cyclist if AB represents north-south. Now this is not AB. We were considering this as AB. No, diameter is north-south. So if it is north-south, so what is the displacement of the cyclist? So waiting for your answer. Okay, Until then, I'll very soon I'll come up with the next part or with the next topic. So until then, bye bye. Take care. Have a nice day. And yes, don't forget to click on the bell icon and please subscribe to the channel to get immediate notification of further videos. Thank you. Bye bye.